Hey, it's Mrs. Cat, and I'm here to walk you through how to use your graphs from experiments 1 through 6 on the KMT and properties of gases lab and the PhET simulation to help you with your reasoning and your particle diagrams. Um, I've got my graph here for experiment 1. As you notice, I don't have a claim written. I hope that you already have one written before you submit it, as that was part of your instructions. But I want to talk about checking your claims. So hopefully you have volume. I know you do because this one was done for you, and pressure as your variables that are graphed. As you write your claim, you want to think about which of these variables that changes is the independent and which one is the dependent variable. Remember, independent variable, the experimenter changes purposefully to see what the result is going to be with your other variable or variables. In our case, if we take a look at how our increments change for volume, we can see that they increase very steadily by 1 liter. That seems pretty planned and specific. And so to me, that's a clear sign that the experimenter changed the volume of the container on purpose and that the pressure change was a result of the volume change. So when I write my claim, I want to show that by saying that the volume changed caused the pressure change. So we want to say as volume increases, pressure decreases, right? Okay, if you already have reasoning to start out with, great. If not, let's talk about how to use this PhET simulation to help us. So when you open up the simulation, you want to go ahead and click on that first option of ideal. And notice that there's some different things to choose from. You can change the size of the container by moving the handle here. You can open and close the container here. We can change the temperature by heating or cooling the gas particles in there. We have a pressure gauge, and then we have a pump here. This is how we're going to put our gas particles in. So I'm going to go ahead and do that. I'm just going to put 1 pump of particles in. Doesn't really matter. These are the heavier particles, but we're only going to use 1 type of particle, so it doesn't really matter. I'm going to change my temperature from Kelvin into Celsius and my pressure from atmospheres into kilopascals. That way the units match with what we have recorded in our lab data. Okay, so remember, the volume of the container was changed purposefully and is the independent variable, and the change in pressure is going to be our dependent variable. Okay, the 2 things that were held constant were the amount of gas and the temperature. Now, notice up here in the top right-hand corner, we can choose what we want to hold constant. Temperature is one of those options, so I'm going to choose that by clicking Hold Temperature Constant. We don't have an option to keep the amount of gas constant because we control that by either pumping in more gas or leaving the amount of gas the same. All right, so what I want you to notice is what's happening with the movement of your particles. I want you to see how many collisions you notice happening on the walls of the container. If you would like, there is a collision counter. If you click that option on, it's going to turn on a counter. You can change the time period. It's set at the middle, which is 10 picoseconds. But if you wait till you've got your particles all spread out, you can start to count those wall collisions for that time period, and you can get a reading of that, and that's going to help you with your comparison. Okay, so here's my first volume. This is going to be the smallest one. I have 39 wall collisions. Okay, notice our pressure reading is jumping as that changes. We could take a pause, right, and get a reading. So we have like 690, right, and it's jumping in between different pressures up to 750, right? So I'm going to change the size of my container a little bit, increase that. I'm going to let those gas particles spread out a little bit more. I'm going to see what starts to happen with my pressure value as it's going down. Right? Another way I can keep track of pressure is by keeping track of my collisions. Right? So I've let those particles spread out. Let's take another sample of how many collisions we have with the wall of the container. It was 39 before, and now it's down to 38. Okay. If I change the size of my container one more time, let's make it even bigger. Let's let all those particles spread out. Notice again, temperature is still 27, but now my gas pressure has decreased even more. Right? Let those particles spread out. They're still pretty clumped together on that right-hand side. Give it some time. We can start to see, if I do another count of my wall collisions, that this time it went down to 31. Okay. If you want to keep track of how many particles you have, you can turn on this particle menu and it'll tell you. I think one pump gives you 50 particles. Okay, so as the container got bigger, we had fewer particle collisions and we saw that the pressure went down, right? So that's what we want to say is our reasoning, right? As the volume increased, there were fewer collisions with the side of the container, resulting in less pressure, right? Okay, so one more thing that we want to do is particle diagrams. Now, you do not have to do your reasoning and your particle diagrams in this document. If you would like to, you certainly can. I'm going to show you how you can do that really quickly if you want to keep everything all together. Personally, I would prefer to do it on a piece of paper to draw my diagrams and write out my reasoning and then submit that. You do what's best for you. Okay, you are still going to need to have this document and the simulation pulled up digitally. Okay, so if you want to do digital particle diagrams in the same document, go to Insert and choose Drawing. Okay, now I have already created one and I'm just going to copy paste it in here and then I'm going to talk you through what I did. So let me paste this in here. Okay, so what I have are 3 different size containers. I entered these by entering a shape and I chose the cube. You want to choose something that's 3-dimensional. So you can choose the can or the cube, either one, right? I made them increasing in size. I took the color out so it was easy to see the gas particles. Okay, gas particles, I just inserted a circle shape and then I just copy pasted it over and over and over, making sure that my gas particles were the same in number. I kept 5 because it's a nice small number. Okay, and then the big thing that I have seen time and time again with students over the years is forgetting to show whooshies to show movement of gas particles due to temperature, and forgetting to show whammies, which is big here because whammies show collisions, which is what determines pressure of a gas, collisions with the container, right? So what you'll see here, all I did was I used the line tool, okay, to draw lines on my particles. I'm not going to draw them on there because they're already there, okay? And notice because the temperature was consistent all the way throughout and constant through all 5 trials, every single particle only has one tail, right? To show that the movement is the same because the temperature is the same. The difference that you'll see is the difference in the number of collisions, number of whammies. So notice here, my small container, I have 3 whammies shown for 3 collisions to show more pressure. Took that down to 2 in my second set of pictures, and then just 1 collision in the last one. Okay, if you want to do that digitally using the drawing, you can do that. Okay, now obviously I don't really want mine right there on top of everything else, but I can put my particle diagrams right underneath my reasoning. And then what you would do to submit this is to just submit this whole Google Sheet again with your reasoning and your particle diagrams. Again, I don't care how you submit it in terms of whether you do it by hand or digitally, but you do have to make sure you have 6 sets of reasoning and 3 particle diagrams. It's going to be 18 particle pictures altogether. Make sure you keep them simple and don't use too many particles, and make sure that you are showing changes in whooshy lines to show changes in temperatures and show changes in collisions by showing changes in whammies. And remember, just like we saw here, the number of whammies is going to represent any changes in pressure.